Hi, my name is Dr. Tishan. In this video, we are going to find derivatives of exponential functions whose bases are not e. That's what we're going to concentrate on, okay? Let's take a look at the rule for the derivative formulas. So if you're taking the derivative of an exponential function and the base is e, okay, you're going to take the entire exponential function multiplied by a derivative of the exponent. So kind of fun to see the derivative of an exponential function. It differentiates into itself. So it's going to be the entire exponential function times the derivative of the exponent, all right? What if the base is not e? Okay, so remember, e is a number about 2.718. What if the base is not e? Any other number? What if the base is 2? What if the base is 7? What if the base is 5? Then you're almost going to do the same thing, but we got one more component to add. You're going to take the entire exponential function again, multiply by the derivative of the exponent, but then that gets multiplied by natural log the base. Okay, so here, this video is, here the formula is going to show you how to use them. Okay, so we're not going to talk about the why they work and the proofs of them. That's for another lesson. So anyways, let's go ahead and take a look at the examples here. So the very first example, because I want you to compare the formulas between base e and not base e, let's take a look at this, all right? So we want to take y equals e to the 2x, and we're going to find the derivative. So according to our formula here, to find the derivative, I'll call it y prime, okay? You're going to take the entire exponential function and bring it down and multiply that by the derivative of the exponent, all right? So that is what we do. Suppose if you want to write it without grouping symbols, bring the 2 around front, 2e to the 2x power, and then here is what the derivative looks like, all right? So the entire exponential function times the derivative of the exponent. Take the entire exponential function, bring it down, times the derivative of the exponent. That's what you do when the base is e, okay? Now, what do you do when the base is not e? We follow the same pattern, okay? So let's go ahead and get this derivative. Follow the same pattern. Take that entire exponential function, bring it down, 5 to the 2x, bring the entire exponential function down, multiply that by the derivative of the exponent, and that gets multiplied by natural log the base. There's your extra piece, okay? And this is what the answer is, okay? In whichever way you want to write it, 2ln 5 times 5 to the 2x, all right? But these are the pieces you need. You want to take the entire exponential function times derivative of the exponent times natural log the base, okay? Quite honestly, up here, you could use this formula. A to the u works on everything. It works on e to the u as well. All right, think about it. Exponential functions, to find their derivative, you take the entire exponential function, bring it over, multiply that by the derivative of their exponent, and then multiply that by natural log the base. But when you multiply up here by natural log of e is equal to 1, so we don't need it. But it's not wrong to do it, is it? Okay. So any exponential function, really, this is what you're doing. You're taking the entire exponential function times the derivative of the exponent times natural log the base, all right? Let's do 2 more examples that have some other rules involved as well, okay? So here's example 2, y equals x squared multiplied by 2 to the 3x, okay? So we're going to need to utilize the product rule on this, okay? This is our u quantity, v quantity, so u times v prime plus v times u prime. We're going to use the product rule, and inside the product rule, we've got this new a to the u expression here. So let's see what this is going to look like. Let's go ahead and get this derivative. I'll call it dy dx, y prime, okay, whatever you want to do that. So you're going to take that first x squared and just bring it down, all right, and that gets multiplied by the derivative of 2 to the 3x. What do we do with this again? It's the entire exponential function 2 to the 3x times the derivative of the exponent, natural log the base, okay? Remember all those components there, okay? So there's your derivative a to the u plus, bring down the 2 to the 3x, the second expression there, and that gets multiplied by the derivative of the first. Derivative of x squared is 2x, all right? So here's your product rule. When you have a u times v and you need to find the derivative, it's going to be u v prime plus v u prime. You have the product rule, and inside the product rule, we're using power and exponential rule. All right, so we brought the first down, derivative of the second, okay? Derivative of it, a to the u. It's the entire exponential function, derivative of the exponent, natural log the base, okay? Plus, bring the second expression down, times derivative of the first, okay? All right, anytime you use a product rule, anytime you take a function, find the derivative using the product rule. It always takes your function and kind of breaks it into two pieces, right? And dumps it into two pieces. So what we usually do is we take a look at those two pieces and see, is there anything common that we can factor out, so we can try to write this as one term, just to simplify this a little bit, because this looks really, really busy, okay? So what is dy dx? What can we factor out? Okay, so what can we factor out? Looks like we can take out the exponential function for sure, all right? And we can take out one of those x's, okay? You have an x squared here and an x there. So I'm going to factor that out. So we'll take out the x, okay? All right, and then we'll take out the times 2 to the 3x. We'll take that out, okay, of each of the terms, all right? So take out one of the x's and the 2 to the 3x. What do we have left here? We're going to have a 3x ln 2 for the first term. And then this term, we're going to take out the x and the exponential. We only have a 2 left, okay? So this is what the answer looks like when you factor it out, all right? Just a couple of steps, 2 steps and we're done, but it was 2 very busy steps, okay? We had to use the power rule and the exponential rule inside of the product rule, so kind of busy. So here's a little bit of a simplified answer. So we factored out the exponential, we factored out an x, okay? And you can see what the pieces are that are left over, all right? Let's take a look at another example. Example number 3, y equals 7 raised to the 3x power over x to the 3rd. So with this one, we're going to use the quotient rule with the exponential and power rule functions inside the quotient rule. So, all right, so here we go. All right, so let's find dy dx here. All right, so we are going to take the denominator, x to the 3rd, times the derivative of the numerator. The numerator is the exponential, a to the u, so it's going to be the whole 7 to the 3x, okay, times derivative of the exponent, natural log the base, all right? So there's your derivative of the exponent minus the numerator, which is 7 to the 3x, and that gets multiplied by the derivative of the denominator, which is 3x squared, and all of this goes over your denominator squared, all right? So your quotient rule is you're going to take the denominator times you always start with the denominator, times the derivative of the numerator. This whole thing is derivative of the numerator, all right? Minus numerator times derivative of the denominator. All this goes over denominator squared, all right? The numerator, let's go ahead and see what we can factor with this numerator, okay? Because you have the 2 terms. So we can take the exponential, all right? And you have 3 x's here, you have 2 x's there, so we can take 2 of those out. We'll be careful, all right? So let's simplify this a little bit. So dy dx. So in the numerator, we can take out the x squared, all right? And we can take out the 7 to the 3x. Okay, so this first term, when you take out the exponential and 2 of those x's, you have 3x ln 7. All right, and then you're taking out the exponential and the x squared, so minus 3. There's your numerator. Denominator, you have x to the 6th power, because when you have a power raised to the power, right, we have x to the 3rd, the quantity is squared, so that's x to the 3rd, we have 2x to the 3rd, so there's 6 of them, all right? And now, we can cancel x squared, okay? So we can still simplify this one more step to just simplify our answer. So our derivative, all right, simplified, when you simplify the x squareds here, you have 7 to the 3x. We have our exponential function, and then 3x natural log 7 minus 3. Just realizing we could have pulled the 3 out also, but just going to leave it alone. I wanted to pull the x's out so you can see that we can cancel. We're canceling x squared. We're taking away 2 of those x's are canceling, so x to the 4th power. All right, so wanted to make sure I move the x's out so you can see. All right, and here we go. And you could factor out a 3 as well, but then that might require you to write some more grouping symbols there with the exponential out front. Anyways, so here is derivative of exponential function when the base is not e. Okay, base is e, then it's the entire exponential function times the derivative of the exponent, and when the base is not e, entire exponential function, derivative of the exponent, natural log the base. Okay, so that's it for this video. Thank you so much. I hope this helps. Thank you so much for watching, and take care. Thank you.